All right, yesterday we talked about just two lines being cut by a transversal. We didn't say that they were parallel or anything, did we? We just said that they were two lines cut by a transversal. Today we're doing a little different. What we're going to do is we're not going to just have any two lines. We're going to have two, what do you think? Parallel lines, okay? So we're going to take two parallel lines. No, you have to get your own pencil. So two parallel lines and then cut by a transversal. Now, if you just looked at this picture right now, can you say that they're parallel lines? Tell me why they're parallel lines. You can't. Why not, Justin? Because they don't have the arrows on there, right? You cannot make an assumption that these are parallel lines. Just because they look like it doesn't mean that they're parallel lines. So if they tell you, and they can tell you a couple different ways. One way they could tell you is by putting the arrows there. If they put the arrows there, that tells you that those two lines are parallel to each other. So you could tell that these two lines are parallel by the arrows. Another way, they could name them. They could say this is line L and line M, and somewhere up there they might say that line L is parallel to line M. There could be a couple different ways that they could tell you that they're actually parallel lines. Right? The arrows are good enough, okay? If they tell you with the arrows, that's good. Let's put some angles in here. 1, 2, 3, 4. We'll label it just like we did before. All right? So what we learned yesterday was just the names of the relationships between these angles. It really was not that significant yesterday. All right? It was just helpful in us communicating which angles I'm talking about. So if I said, the corresponding angles, you know which angles I'm talking about if I say the corresponding angles. If I said, look at the two pair of alternate interior angles, you know which angles I'm talking about, all right? But it really didn't help us yesterday solving for anything, right? Finding what angles are equal to each other or anything else, okay? What I'm going to do is this. Let's take a look at angle 1 and angle 5. What would the relationship between those angles be? What is the name of that relationship? They're corresponding. Very good. They're corresponding angles. But since we have parallel lines, things are a little different now, okay? We do know that they're corresponding, but we also know something else. And we know this because of a thing called a postulate. You've probably heard of the word theorem before, right? Pythagorean what? Theorem, okay? Theorem is just a rule. It's somebody that said, okay, this is what's true. Well, postulate is kind of like that, except a postulate is just accepted without any proof. You don't have to prove it. You just accept it as fact. So if somebody says this is a postulate, you're not going to sit back and say, oh, just prove it. Go ahead, prove it. You can't really prove a postulate. It is true, all right? Because if we took a protractor and we measured these angles, you could find out what might be true about them. A postulate is just something that's accepted as fact. All right? Everybody with me? Calvin, you getting all this down? No, you're not. So, so this postulate right here is accepted without fact. And let me show you what this postulate says. The postulate starts off like this. It starts off with an if. It says if you have two parallel lines, and do we have two parallel lines? Actually, I put just lines. I should put what? Parallel. Forgot that. If two parallel lines. So if we have two parallel lines, now technically it says cut by a transversal. I'm not going to write all that in there because I don't know if that's something that we need to write down, okay? But if two parallel lines are cut by a transversal, then this is what the postulate tells us. Then the corresponding angles, I'll shorthand corresponding, then the corresponding angles. Now let's take a look. We already said that 1 and 5 are corresponding. So somebody tell me, Q, tell me something about 1 and 5. What does it just look like to you? If you were just to say, look at angle 1 and look at angle 5, what might you think might be true about 1 and 5? Yeah, it looks like the same, don't they? 1 and 5 look the same, don't they? And they actually are. And if you took a protractor and measured it out, you would find out that 1 and 5 are exactly the same. So this postulate says this. If you have two parallel lines, then the corresponding angles are what? Are equal. Let's say equal. Or in geometry, a lot of times we say what? What's that symbol? Congruent, right. All right, you can say either way. I don't really have a problem with you saying equal. Some teachers do have a problem with saying they always say congruent. They never say equal. I'm okay either way. I don't really care. So that's what this postulate tells us. If you have two parallel lines, then the corresponding angles are equal. So according to this postulate, let's write down some angles that are equal to each other. We already mentioned 1 and 5, didn't we? So let's write that down. So angle 1 must equal angle 5. Justin, give me the other one. 2 and 6, okay? Do I put one arc for 2, though? Because is 1 and 2 the same? No. So I put 2 arcs, right, just to show that they're different angles. All right, so 2 and 6 are equal to each other. Let's write that down. Angle 2 equals angle 6. Freddie? What's that? I thought you were going to answer a question here. Just wait till I'm finished this part. What else is equal here? 3 and 7. Good. So 3 and 7 are equal. Now watch. How many arrows or how many little arcs am I going to put for 3? Am I going to put 3 or 2? I'm going to put 2. Why can I put 2? Because 2 and 3 are exactly the same, aren't they? Tell me why 2 and 3 are exactly the same. Because they're vertical angles. Very good. So 3, I'm going to put 2 arcs right there. And what did you say was equal 3 and what? 7. And look at the things with all with 2 arcs. Look, 2 and 3 are equal, so they have the same number of arcs, don't they? 6 and 7 are equal to each other because they're vertical angles. They have the same number of arcs. Everybody see that? Okay, so 3 and 7 are equal because of what reason? Why are 3 and 7 equal? Because they are what kind of angles? Because they are corresponding. 3 and 7 are corresponding angles. 2 and 6 are equal because they're corresponding angles. And let's write down 3 and 7. And we got one more pair that we left out. What did we leave out? 4 and 8. Good. So angle 4 equals angle 8. So let's write that down. Let's make my angle symbol look a little better. Angle 4 equals angle 8. Everybody understand that? All right, so if you take a look at it, 1, 4, 5, and 8 are all exactly the same angle. All right, 2, 3, 6, and 7, again, are all exactly the same angle. All right, so that's very, very important. Let's take a look at another thing. Look at 1, 4, 5, and 8. They're all equal to each other. What type of angle is angle 1 and angle 4 and 5 and 8? Well, 1 and 4 are vertical, but 1 and 8 aren't vertical. 1 and 5 aren't vertical. But what type of angle? We talked about different types of angles. We talked about acute, obtuse, right, straight angles, and all that. What is 1, 4, 5, and 8? They look acute, don't they? Yeah, they're definitely acute. They're less than 90 degrees. So look at it. What you could think also is this, that all the acute angles, what do you think, are equal to each other, right? Are the same, but we'll say equal, right? Now this only works if what's true about the lines. They're parallel. This only is true. See, it says if two parallel lines. This only works if the lines are parallel. So all the acute angles are equal. What do you think about the obtuse angles? Look at them. 2, 3, 6, and 7. They're all obtuse, aren't they? And guess what's true about them? They're equal to each other as well. So all the obtuse angles are equal as well. So that's kind of a nice, easy way to see it. All right, let's do, I'll tell you what, yeah. Let's do this. Now you wrote that postulate down. I'm going to erase it just because I want to fit all this stuff in right here. Since we marked all this stuff, look at 4 and 5. What's the relationship between 4 and 5? What are the names? The stuff we did yesterday. They're alternate interior angles, right? They're alternate interior angles. Now, since I've marked everything up, what do you think might be true about 4 and 5, the alternate interior angles? Do they equal 180? They're equal to each other, aren't they? Look at 4 and 5. This has one arc and this has one arc. So 4 and 5 are equal to each other. What about 3 and 6? They're equal to each other. They're both alternate interior angles, aren't they? So guess what I can say? Now this one's not a postulate. This one's actually called a theorem. Now they number the theorems, but I really don't care about the numbers of these theorems. I mean, I know some teachers that make you memorize the theorem number and the exact wording of the theorem. I think that's ridiculous. I think it's just memorization, and I don't think that's all that important to do. Because I could teach out of one book. This book might be theorem like 3.1 or something, and it is 3.1, but I could teach out of another book. They might do this stuff in chapter 2, so they might call it theorem 2.1. Make sense? So it just depends on what the author calls it. There's nothing there's nothing sacred about calling these theorem 3-1, 3-2, 3-3, and all that stuff. We're just going to say it's a theorem. And here's what the theorem says. Starts off the same exact way. If you have two parallel lines, then, now what did we just say? Then the what? 4 and 5, what are they? Right, then the alternate interior angles are equal to each other or congruent. All right, so we got two things so far. The postulate says if two lines are parallel, the corresponding angles are equal. This one is a theorem. Now, a theorem can be proven, and we kind of did. We kind of showed that 4 and 5 were equal to each other. By knowing that 1 and 5 were equal, watch, 1 and 5 are equal, 1 and 4 are equal. Everybody see this? Look. 1 equals 5 because of corresponding angles. 1 equals 4 for what reason? What would be my reason 1 and 4 equal each other? Vertical angles, right. So this is because of corresponding angles. This is because of vertical angles. So watch. If 5 equals 1 and 4 equals 1, tell me something about 5 and 4 then. They have to equal each other. Would you agree? If they equal the same thing, then they have to equal each other. So 4 and 5 must be equal. That's actually a thing called a proof. We do proofs in geometry. We probably won't do too many proofs in this class. In the honors class, we do a lot more proofs. But that's actually a proof in geometry. So we actually proved it. Theorems can be proven. Postulates are just accepted without any explanation. Okay, they just tell you that that's true, and you believe it. Do you see the difference between a postulate and a theorem? It kind of looks the same, doesn't it? But the postulate is just accepted fact. A theorem can be proven. Anthony?
So that's true for interior angles, would it be the same for exterior?
Very good. Exactly right. Because look at the exterior angles, the alternate exterior. 1 and what is alternate exterior? 1 and 8. Alternate. Remember, complete opposites. So 1 and 8 are alternate exterior angles. Look what's true about 1 and 8. They both have one little arc on it, don't they? So they must be equal to each other. So I could say this. I could say if you have two parallel lines, then what else is true? The alternate what? Exterior angles are equal to each other or congruent to each other. All right, so that's a second theorem. That's our second theorem that we learned. So we've got a postulate and two theorems right now. All right, so we did corresponding, we did alternate interior, we did alternate exterior. What's the fourth thing that we did yesterday? What's the fourth word? Consecutive what? Interior. Consecutive interior angles. Which ones are consecutive interior angles? 4 and 6, right. 4 and 6 are consecutive interior angles. And what's the other one? 3 and 5. Now, does this whole thing follow? Are consecutive interior angles equal to each other as well? Take a look at them. Is 4 and 6, is there any way 4 and 6 are going to be equal to each other? No, there's no way, because 4 is what kind of an angle? It's acute. What kind of angle is 6? It's obtuse. Is there any way an acute angle can equal an obtuse angle? No, absolutely not. Because an acute angle is less than 90, and an obtuse angle is what? It's bigger than 90. Can you have one number that's both smaller than 90 and bigger than 90 at the same time? No, you can't. So 4 and 6, there's no way they're equal to each other. So let's find out if there is a relationship between 4 and 6. Okay? So let's do this. Look at 3 and 4 right here. Tell me something about angle 3 and angle 4. They're supplementary. Good. So they add up to 180, don't they? Everybody watch what I'm doing? This is pretty interesting. Watch. 3 and 4 add up to 180. What do I want to do now? I want to do 4 and 5. Let's do 4 and 5. Look at 4 and 5. What did we just say? They're alternate interior angles, right? So what must be true about 4 and 5? They equal each other. Good. So angle 4 equals angle 5. Now watch what I'm going to do. I'm going to take 4 right here and replace it with what 4 is equal to. What's 4 equal to? 5. So what can I do? I can take this and replace it with angle 5, couldn't I? Since they're exactly the same thing. So I could write this how? Angle 3 plus what? Angle 5 equals what? 180. So let's take a look at this. Look at 3 and 5. What's the relationship between 3 and 5? They're what? They're consecutive interior angles, aren't they? So what must be true about consecutive interior angles? They have to add up to equal 180, right? Okay, or what's a better word that we can use? They're supplementary. So let's write this down. This is another theorem. It says if we have two parallel lines cut by a transversal, I just kind of leave that out. But if you have two parallel lines cut by a transversal, then the consecutive, I'll just shorten it, interior angles, they're not equal to each other, are they? Are 3 and 5 equal to each other? No, there's no way. What are they, though? They are supplementary, right? And I'll just write that out. Supplementary. All right, or they're supplements of each other. They're supplementary. So really, everything else is equal except for the consecutive interior angles, right? The consecutive interior angles aren't equal to each other, but they are what? We just said it. Supplementary. Thank you. Just making sure you're paying attention. All right, let's do a little example here with these. All right, let's go to the white line again. Now, it doesn't have to be like the lines, the parallel lines don't have to be horizontal like we drew earlier. They could be slanted. There's no problem with that. Let's make this one red just so we stay consistent. We'll do a real easy one. Watch this. I'm just going to give you one angle. Let's say this angle right here is, let's say it's 50 degrees. Okay? If I just gave you that one angle, oh, I got to say something about these two lines. Let's say these two lines are parallel. Right? Because you can't do this unless those two lines are parallel, okay? So if these two lines are parallel, I told you this is 50, you should be able to find every single angle in here. So let's go through and find some. Here's 50. What's the easiest? The easiest for me is to look at this one right here. This is going to be 50. Why is that going to be 50? Give me reasons to back up everything you say. Because they're what? They're vertical angles. Very good. They're vertical angles, okay? What about this angle down here? That's 50 as well. Why is it 50? Okay, it's corresponding to this one, right? Or you could have another choice. What? It's what to this? Very good. Say it. Alternate interior angles. That's right. Okay, so these two right here are alternate interior. These are corresponding. So they have to be equal to each other. Agreed? Anything else I can do with that 50? This one right here. So what's that? That's 50. Back up your reason with that. Vertical angles. Good. So check it out. Look. These are corresponding. Good. They're vertical, right? Alternate interior, corresponding, right? A whole bunch of things going on here. Would you agree? All right. What about the ones that we left out? What's this angle right here going to be? 130. How'd you get that? That's right, because it adds up to 180 degrees. So you took it away from 180 degrees. So 180 minus 50 is 130. So if this is 130, let's keep going. What's this one? This has to be 130. What about this one? Yeah, and this is 130 for several different reasons. It's supplementary to the 50, right? It's the same as this corresponding one right here, isn't it? It's supplementary to this 50. It's supplementary to this 50 because they're consecutive interior angles, right? There's lots of reasons why that's 130. And then this has to be 130 as well. Same thing, right? Vertical angles. It's supplementary to this one and this one. It's corresponding to this one. There's a whole bunch of stuff going on. It's alternate exterior with this one up here, right? Are you getting all the reasons now? Okay. So there you go. So if I just gave you one angle, you should be able to find all the rest of them. Pretty easy to do, don't you think? I think so. All right. Now here's what they're going to do. Make it a little bit tougher for you. Not much, but a little bit. How much time do I have? When do we get out of here? I have 1 minute. Is it 40? Okay, I got like 3 minutes. This is where I ended up last period. I had 3 minutes left at this spot. So let's do an example. Here it is. Okay, watch this. Don't pack up yet, just because I said there's 3 minutes left. Don't pack up. Okay, watch this. They tell you, they write a whole bunch of angles and they tell you what angle is equal to what, but I'm just going to fill it in. This one right here is 2x minus 17. That angle right there. And angle 1, which is that top left one, is 85 degrees. And they ask you to solve for x. They tell you, I hope you're paying attention because this is the kind of stuff you're going to be doing on the worksheet. Yeah, of course. So watch. Let's take a look at these. We got to find the relationship between this angle and this angle right here. Are they equal to each other? A lot of people are so quick to make things equal to each other. Sometimes they are, sometimes they're not. You got to look. They're not equal to each other. They're not corresponding. They're not alternate interior. They're none of that stuff. But if this is 85, tell me about this angle right here. That's got to be 85. Now, tell me something about these two angles. They're supplementary because they are what? What's the name of them? Consecutive interior angles. And consecutive interior angles are supplementary. So how do I set up my math? What do? Do I just set them equal to each other? Shannon? Very good. You add them together, right? And then you set it equal to what? 180. Everybody see that? You've got to understand that they add up to 180. Don't just set them equal to each other. Some people are just way too quick just to set things equal to each other. We're running out of time, but I'll let you do the math yourself, okay? You do the math. That's all your work right there. And x is equal to, I think, 56. All right? So you can try that on your own. You have that in your notes. So you do the math and you solve for it, and x is 56. Make sense? Pretty easy stuff, huh? All right, so let me give you a worksheet, and that's what you're going to be doing tonight. That will be due tomorrow. So it's worksheet 3-2.